So now we're on to question number 2. Assuming this is the exact same print. This says 2017. I'm assuming 2019. I'm assuming this is the same. I hope it is for you guys. So what are we doing? This is the reaction. The Nernst equation can be shown to evolve to this equation, which accounts for the activities. B is the molality. Graph the following data. So they want the standard, which is this. So you've got the measured E, which is this, and then you've got the molality, but the molality of HCl, I was going to say, I'm looking at this equation, the molality of silver chloride solid makes no sense. It has to be monitoring the molality of HCl. So as it goes up, the measured E is going down. The y-intercept is going to be the E naught value. So it looks to me, if you have E plus 2RT, right? I just noticed something here. F ln B. Interesting. I don't remember this stuff. So what I'm going to do is take a quick look at my notes here. All right, I'm back. So I just dawned on something. A lot of students, what they're doing with that ln B is they think it belongs multiplied by F in the denominator. That's not true. If you look in our notes or in the textbook, this is one of the most famous, most derived things in all of electrochemistry. So in our notes, we derived it to this point. See how it's, do we have a 2? Yeah. 2RT divided by just F, right? And then you multiply by ln B. So we got to make sure it's done that way. So that is a little bit of an issue. So you can see how I almost made the same mistake. Ln B does not belong there. It belongs here. Aha. So that makes sense. And if I had C, B to the 1/2 plus E naught. So this is your Y, mx plus B. So x is B to the 1/2. Your slope will be C. This is the answer we're looking for, which will be that. So given the data, how would I probably make an Excel spreadsheet for this? Your molalities are given. So I would probably take the square root of them. So for instance, your first one is 3.214. This is times 10 to the minus 3. Then it goes 5.619 times 10 to the minus 3. Ding, ding, right? You've got 4 data points, and you get another one and another one. Take the square root. This will be your x-axis right here. And then you're supposed to do what? You're going to have E measured values. So the first one was 0.52053, and then it goes on. You need to calculate this. So in your Excel spreadsheet, you're going to have E plus 2RT over F times the ln of B. So in Excel, you have to make sure that you're calculating this right. That B will come from here, right? The T we know is 298, unless told otherwise, and plus it's standard, it's 298, R is 8.314 joules per K per mole. Faraday thing is 96485, and that's coulomb per mole. Yeah, so what's going to happen is, what does this quantity do as the concentration goes up? It turns out it's a graph that looks like that. Your answer will be that. And your answer should be somewhere between 0.2 and 0.3. I'll let you guys calculate exactly, but this is it. I mean, graph this. This is your Y against that X. So it should be square root of B, and this is going to be E plus 2RT over F ln B on the Y. So that is number 2.